I am covering in this video binomial distribution. So let's start from with the basic question. Find the mean, variance, and standard deviation for the binomial of the binomial distribution with the given values n and p. So n is given 90. Okay, that's not fair, jumping around. All right, here. N is equal 90, probability is equal 0.9. All right. So mu, which is a mean, let's start with mean. Mu is equal n times p, which is going to be equal 90 times 0.9. Okay, it's going to be equal 81. Next, to find variance, so mean, variance, standard deviation. Variance, sigma squared, is going to be n times p times q. So if p is 0.9, q is going to be 1 minus 0.9, always, because q is equal 1 minus p. Because q is a complement of p, which means if p is 0.6, q is going to be 0.4. If p is 0.8, q is going to be 0.2. Okay, so here it's going to be 0.1. All right, so sigma squared is equal, that is equal, n is 90, p is 0.9, and q is 0.1. So it's going to be 8.1. Okay, and standard deviation, sigma, is equal square root of sigma squared, which is going to be equal square root of 8.1. Well, I believe you can punch on calculator and figure out 8.1 square root, how much it will be. Moving to next question. 72%, so let me mark down, 72% of adults in a certain country believe that life on other planet is plausible. You randomly select 5 adults, so 5 adults, this is going to be our sample size, and ask them whether they believe that life on the other planet is plausible. The random variable represents the number of adults who believe that life on other planet is plausible. So, random variable, which means from 1 to 5. Okay, so find the mean, variance, and standard deviation of the binomial distribution. All right, the same way, so 72%, it's going to be our p, probability of success, where q is going to be equal 1 minus 72%, you get 28%, yes, and from there you calculate exactly same way. Mu is equal n times p, 5 times 0.72, and sigma squared is equal n times p times q, n is 5, p is 0.72, and q is 0.28. So you can calculate it. I didn't do it, so I left it on you. And that will be variance, and standard deviation will be square root of sigma squared, which means it's going to be square root of this expression, 5 times 0.72 times 0.28, and you will get your standard deviation. Okay, next one, there are a lot of calculations, that's why I put in there not to waste too much time on writing down. Might as well I'll just cover and move on. 43% of US adults have very little confidence in newspapers. You randomly select 10 adults. Randomly select 10 adults. That's already Right here, it's our sample size, 10 adults. Find the probability that number of US adults who have very little confidence in newspaper is A, exactly 5. Here it is. X is equal 5, and then at least 6, and then, okay, B and C. We'll do it. So first of all, for probability distribution, this is the formula. Okay, I can even make this red color so you would it would strike your eye, so you won't forget. There we go. So now we need to find for in A that we have exactly 5. People don't they have very little confidence in newspaper. If we have 5, so what do we need? We need to know N, we need to know X, and we need to know P and Q. Let's see what we have, what we don't have. N, we said it's equal 10. Okay, we have it. X, it's given in the A. Here it is, exactly 5. So I wrote down, we have it 5. P is 0.43. And Q we can calculate accordingly. 1 minus 0.43 gets 0.57. Okay, actually this Q I can move out of this question A because Q is going to be common for all these questions. Therefore, I will move it out here. It's a common calculation for all of them, all A, B, C. All right, so for X is equal 5, let's find out probability of 5. Let me show you how we're going to solve. So N factorial, this is what we call factorial. So 10 factorial, I will show you how to calculate factorial in a minute. N minus X factorial, which is N 10 minus 5, 10 minus 5 factorial. Let me use different color. 10 minus 5 factorial, and then times X factorial, since X is 5, so 5 factorial. Next, here we have time in this formula, P to power X. So how much is our P? 0.43, probability of success, here 0.43, to power X. Since my X is 5, I'm writing down power 5. Next, Q I have 0.57 to power N minus X. N is 10, X is 5, 10 minus 5. Here we go. So, how we are going to solve this? So when you have factorial of the number, let me do some drafting here. Factorial of 10. That means you multiply the entire sequence from 10 to 1. 10 times 9 times 8 times 7 times 6 times 5 times 4, 3, 2, 1. But you don't have to open every time all the way to the end. You can stop any time, 10 times 9 times 8, let's say, and put factorial, okay? So here what I have, let me clean this, not to have it mess, because I have too much writing here anyway. All right. So factorial of 10, see I'm opening here, 10 times 9 times 8 times 7 times 6, 5 factorial. Why I stop at the 5 factorial? Because at the bottom I have 10 minus 5 factorial, right? So 10 minus 5 is going to be here, 5 factorial. That's why I open till 5, so I can cancel this with this. Yes? Let me rewrite it. I don't want it to be messy, since you already know. 5 factorial. Canceling. Here also 5 factorial. I am canceling. Now here I have another 5 factorial. So this one I have to open 5 times 4 times 3 times 2 times 1. Yes? Okay. So what does that mean? I'm going to cancel with each other. So 5, this 5, I canceled with this 10, I got 2. 4, I canceled with this 8, I got here 2. 3, I canceled at the bottom, I canceled with 9, I got equal 3. 2, I canceled with 6, I got 3. And that's all. So I had clean, what's left? 2 times 3 times 2 times 7, and then times 3, and that's it. So if you multiply all these numbers, you are getting 252. And then here, 0.43 to power 5, it gives us 0.0147. And 0.57 to power 5, it gives us 0.06. And answer is 0.222. Question B. So find the probability that number of US adults who have very little confidence in newspaper is at least 6. At least 6 meaning 6, 7, 8, 9, and 10. Why till 10? Because total sample size is, we have here 10. So, at this point, what I'm going to do, at least 6, I'm going to calculate probability from 6, from 7, from 8, from 9, from 10. And then at the end, I'm going to add them up because it's greater or equal 6. So let's start. A couple of them I will explain, the rest I will won't go over same operation over and over. So our formula, factorial 10, here it is, 10, n factorial, which is 10 factorial. I have here 10 factorial. Next, n minus x factorial. N is 10, x is 6. 10 minus 6 factorial. And here I'm plugging x factorial, which is going to be here 6 factorial. Okay. And after that, I have here p to power x. My p is 0.43, to power x is 6, right? Here it is, to power 6. And q is 1 minus 0.43, right? It's 0.57, it's right here. 0.57 over to power 10 minus 6, because n minus 6 here. N minus 6. So we have 10 minus 6. So again, opening 10 factorial, look here. 10 minus 6 is factorial 4, but 6 factorial is greater. So I'm opening till 6 factorial and canceling this 6 factorial with each other. And then 4 factorial I'm opening at the bottom, 4 times 3 times 2, and start canceling with each other. 4 I canceled with 8, 3 I canceled with 9, 2 I canceled with 10. So I got 5 times 3 times 2 times 7. And times 0.43 to power 6 is 0.06. And 0.57 to power 4, it is 0.1056. And the answer is 0.14. So the same way we are continuing a probability of 7, which is x is equal 7. So we have 10 factorial over 10 minus 7 factorial times 7 factorial. And then 0.43 to power 7, 0.57 to power 10 minus 7, because n minus x. Okay, the same way here again opening 10 minus 7 is 3 factorial, and here I have 7 factorial. So this is 3 factorial, this is 7 factorial. Obviously on the top I'm going to open till 7 factorial. Here it is. So I can cancel with the 7 factorial, and this 3 factorial from here I'm opening 3 times 2. I just dropped 1. I didn't put 3 times 2 times 1. Okay, so 7 factorials is gone with 7 factorials, and 3 cancelled with 9, 2 cancelled with 8. That's it. I have done left 10 times 3 times 4, and times 0.43 to power 7. This is this much. 0.57 to power 3 is this much, and that will give me 0.06. So the same way I calculate for probability for 8, 9, and 10. Let me shade it. 7, 8, this is 9, and this is 10. Okay, by the way, important thing, probability of 0, not probability, factorial of 0 is equal 1. Just so you know. Here I have 10 minus 10, because 10 out of 10. So 10 minus 10 is 0. That's why I put down factorial of 0 equal 1. And 10 factorials will be cancelled with 10 factorials. And here also 0.57, it's going to be 10 minus 10, right? Because n is 10, minus x is also 10. So you get 0. And any number to power 0 will give you 1. So you ended up, this piece, this fraction is equal to 1 times 0.43 to power 10 is equal this much, 0.00022, and obviously it's equal 0.00022, and this 0.57 to power 0, it's 1 also. So since we need probability at least 6, which means 6, 7, 8, 9, 10, so we are adding up 6, 7, 8, 9, 10, and result is this, 0.221. All right. Now to go this calculator, you can put on a calculator. There is a bunch of calculators online. You can plug in and get the results, or you have calculator yourself also, I'm pretty sure. Question C, it's find the probability that number of US adults who have very little confidence in newspaper is less than 4. Probability less than 4. That less than 4, that's x, less than 4. Here it is. C. Less than 4, meaning 4 is not included, but included. Probability of 0, probability of 1, probability of 2, probability of 3, and then you add them up. How you going to do 0? Just exactly same way we did here. Let me write down for 0, and the rest you can do it by 1, 2, 3, because it's the same calculation we did here, which means probability of 0, it's going to be, so first you need to calculate this probability of 0, 1, 2, 3, and then add them up. So I'll show you 0 one more time. So it's going to be 10 factorial, because our total is 10, and then 10 minus x, our x is 0, right, factorial, times our x factorial, which is going to be 0 factorial, and then probability of success, which was given 0.43 to power x, which is going to be 0, and then times probability of q is 1 minus 0.43, it's going to be 0.57 to power n minus x. 10 minus 0, it's going to be 10. Okay, you can solve it. So this is going to be 1. This is going to be 10 factorial, which means you can cancel 10 factorial with 10 factorial. Let me move this a little bit down. So let me write down it more clean. Okay, 10 factorial, because 10 minus 0, 10 factorial, and this 0.43 to power 0, it's 1. So all you have left, 0.57 to power 10. You find out and you write down here the answer. And then same way, instead of 0 everywhere you plug 1, and then instead of 0 plug 2, 3, and then add them up. Okay? Next question. 42% adults favor the use of unmanned drones by police agencies. 12 US adults, with 12, it's right here, it's going to be our sample size. 12 US adults are randomly selected. 42% that it was given here, it's going to be our probability of success, which means automatically probability of failure is going to be 1 minus 0.42, 0.58. So find the probability that the number of US adults who favor the use of unmanned drones by police agencies is exactly 3. So those are same problems. Exactly 3. Plugging x is equal 3. Sample size is 12. 12 minus 3, and then factorial 3. And then solving 0.42 to power x, which is 3. 0.58 to power n minus x, which is 12 minus 3, and you solve it. Okay, then that will be your answer, exactly 3. This is your A. Next, B, at least 4. At least 4, it's going to be, this is your B. At least 4, since total we have 12, it's going to be 4, 5, 6, 7, 8, 9, 10, 11, 12. Or, if we have 4, if we have a probability of 3, so total is 12, right? Sample size 12. If we know this 3, right? So if I do 12 minus 3, right? I will get the rest, correct? But instead of sample size 12, we are dealing with probability. So this will be probability for 3. And here I will have 100%. This full piece is 100. This whole piece is 100%. So I have to do 1 minus, and whatever probability of 3 I have there left. So x is greater equal than 4. It's easier to do 1, meaning 100%, minus this 3, right? If this is 100% minus probability of 3, I will get probability of x greater equal 4, this piece. Therefore, 1 minus probability x less equal 3 is equal. Less equal 3, this is 3, but we need less equal, which means it's going to be 0, 1, 2, and 3. 3 is already, we have it. All we have to find out, 0, 1, and 2. You already know how to find out, right? And you do 1 minus probability of 0 plus 1 plus 2 plus 3. Once you add them up, you subtract from 1. And you will get your probability x greater than 4. All right? And C, less than 8. We need to find C. It's less than 8. Less than 8, what do we have here? So either I can find out probability of 0, 1, 2, 3, 4, 5, 6, 7, and then add them up. Or I can get 8, 9, 10, 11, 12, and subtract from 1, just like I was telling you in the previous one. If this is my 8, and I can find out this 8, which is going to be probability of 8 plus probability of 9, probability of 10, probability of 11, probability of 12. and this is 100% or 1. If I do 1 minus all this probability here, right here we have it, I will get probability is less than 8, because this is my 8 here. Make sense? So what you have to do, find the probability x is equal 8, x is equal 9, x is equal 10, 11, 12. You are plugging exactly the same way to this, like this formula here. N is 12, x is 3, the plug 3, here is 3, here is 12 minus 3, and so on. So every time you take different x, add them up, and then subtract from 1, and you will get your answer. Okay? I left on you to crunch the numbers this time, because I'm in a hurry to post this. I know students are waiting. Next, use the probability distribution to complete parts A through D below. The probability distribution of number of television per household in a small town is, here we have, so here is values of x, how many the household television has. Some household have 0, which is us. I don't have TV because I'm not watching TV anymore. I can watch everything through YouTube. And then how many families have 1, 2, and 3 TVs? And here is probability. Now pay attention, since this is total, all 100% of cases we are looking for. That means if you add these probabilities to each other, you are going to get 1. Right? All right. So let's go through question A. Question A is right here. Find the probability of randomly selecting a household that has 1 or 2. Remember, when we have or, we are going to add them up. So you are going to find 1. We are going to find 2 TVs and then add them up. So for 1 TV, we have here 0.19. Here it is. And then for 2 TVs, we have 0.26, which we are adding up. And we got 0.45. That's all. B, find the probability of randomly selecting a household that has 2 or more, greater equal to 2 or more. That's the same thing I can write down here. Probability of x greater equal to 2 or more. Okay? So 2 or more, we have what? We can either, wait a minute, let me make sure. 2 or more, but we don't know how many, right? It can be just 2, it can be 2 and 3. Therefore, but what we do know that 2 or more, meaning what is left there? If I have, this is 2 or more, right? Then I have left what? 1, and I have left 0, yes? So if I take the whole 1, which is 100%, right? Which is 100%, decimal notation for 100% will be 1. If I subtract probability of 0 and probability of 1, here it is, 0 and 1, right here in this table, see? Then you will get 0.8, which means probability of having 2 or more TVs, it's gonna be 0.8. You can say, why we didn't add 2 and 3? No, you can't, because it doesn't say 2 or 3. It just say more than 2. It can be only 2. It can be 2 and 3. Okay? Therefore, we don't know which one is the case. But subtracting complement, which is going to be 0 and 1, we will get at least 2. All right? Next one. Find the probability of randomly selecting household that has 1 and 3 televisions. So 1 and 3 meaning 1, 2, and 3. Between I would put dashes here, 1 through 3 televisions. So 1 through 3 is going to be 019 plus 026 plus 054. Right here. 19, 26, 54. And we get 0.99. Find the probability of randomly selecting a household that has most 2 televisions. Most 2 television meaning less equal 2, right? Less equal 2. What is left there? Less equal 2. It's left probability of no television, 0. Probability of 1 television and probability of 2 televisions. So here it is. 0, 1, and 2. Let's go back to our table. Here it is 0, 1, and 2. Okay? And we get 0.46, which means 46%. Okay. I think we are done with this question. We need to solve A through D. Did we finish it? Yes, we did finishing. Here is D. So moving to next question. If X is binomial random number, use the binomial probability table to find probabilities below. This table is given in your word problem. So once you click it, the link is given, you can open it. How we are going to find the probability? What you're gonna do? This is your probability table. On the top, horizontally, you have probabilities. 0.1, 0.2, and blah, blah, blah. Vertically down, it's going to be your axis for n is equal 25 because you have several pages for n is equal 20, n is equal 25, and n is equal 15. So you choose the one that is 25. And you find x is equal 8. Here, let's say this is your 8, x is equal 8. And your probability of success, let me mark it down. You are taking x is 8. Okay, here it is 8. And then you take, let me see. You take probability 0.8, which is going to be, let's say, somewhere here, 0.8. Okay. And interception is going to give you 0.00 in this case. And that is for n is equal 25. You have to make sure because there are several n table. So you need to pick 25. Once you pick one more time, n is equal 25 table. So vertically you are looking for x, which is 8 in this case. And then horizontally you are looking for probability of success, which is 0.08, and interception will give you probability that is less than 8. All right. Next, probability greater equal 4. For n is equal 20. So now you have to open n is equal 20. So, and then you need to use probability is equal 0.3. And x is going to be used 4. Pay attention. The table is showing case when x is less than any value, not greater than. So if we have we need to find out x greater than 4, which is in this case, then I need to take 100%, which is going to be 1, and minus less than it's going to be probability of 3. Okay? So, which is going to be here. Because the table shows only for less. See, in this case, it was x is less than 8, so we didn't have to do any trouble. Just go to table. X you have, a probability you have, sample size 25 you have, and you got intersection, your probability. But when you have greater equal, then you have to take 1, which is 100%, and minus by 1 less. If it's greater equal 13, then you have to subtract x is less than 12. If you have x is greater than 15, then you have to subtract x is the less equal 14. So left over to the right, to the left, the one goes to the left. Okay? And here we find from the table x is equal 3. So again, let me show you here real quick. So I'm opening table that where n is equal 20, and then I'm taking finding my x that is less equal 3. Let's say this is 3, and probability 0.3. Here it is, 0.3. Interception is 0.228. Once you subtract, you will get probability of x greater equal 4, which is going to be 0.772. All right. Moving to question number 13. All right, so since the table shows only for less or equal, but in this case we have sharply equal. X is equal 13. Okay, then what we are going to do? We are going to to find x is equal 13, we are taking x is less equal 13 and minus x is less equal 12. That will give you 13 in the middle. Okay, so look here. Let me show you. This is my 13. This is my 12. So I want to know how much will be my 13. So less than 13 is this. Less than 12 is this. So if I subtract from each other, I will get the piece I am interested, right? This one. Yes? Let me change more lighter color. This one. Okay? So when you need to find precisely probability for precise value of x, so you take less equal of that number, which is less equal 13, and then minus less equal by one smaller number, which is 12 in this case, and then subtract from each other. Both of them are equal 1, so difference is going to be 0. You know now how to work with table, right? So again, you are going to take your value of x, 13, for case of 13, probability 0.4, it should give you 1. And then you are going to look for less equal 12. So if this was 13, let's say this is your 12. Probability is the same, so you come here and you will find your 1. So therefore, difference is going to be 0, which means probability for x is equal 13 is equal 0. And the last question I'm going to cover is on cumulative binomial distribution. Cumulative binomial distribution. It's going to be different table here. Let's see. A literature professor decides to give a 10-question true-false quiz to determine who has read an assigned novel. She wants to choose the passing grade such that the probability of passing students who guesses on every question is less than 0.1. So this is a trap for students practically. All right, what score should she set as the lowest passing grade? So let's see what we have. 10 questions, true, false, here it is. N is equal 10. So if it's true, false, that means probability of success is going to be 50-50, right? Okay. So we need to find this K, meaning how many questions it says, what's the passing grade? So K is our passing grade. So X has to be more, at least this K, right? And that is equal, that would gonna be less than 10%, right here, 10%, all right? So less than 10% are going to pass the grade, the test, and we need to find what's the passing score here, which is in our case is K. Okay, to find probability of X is greater than K, let me see if this is my K. So again, to find probability greater than K, because table doesn't show greater, table always shows less. So we have to take this one. This is going to be K minus 1, since I don't know how much K is. Therefore, I put in the format of X, K minus 1. Because if K is 14, then K minus 1 will be 13. If K is 16, K minus 1 will be 15, right? So X that is less than K minus 1, here it is, subtracting from 1. And it's going to be less than 0.1. This is a condition for passing grade. X greater equal K, we rewrite in the format that is less equal, and that's what's going to be 1 minus probability of X less equal K minus 1. I hope you understood why I do K minus 1. Because if it's, remember we were looking here, where is it? Is it 13? Then it can have to be less than 12, do minus 12. Here also, I should have somewhere here. No, I thought I did it. Maybe I cleaned it. Well, whatever. So if it's greater than K, then I have to take less than K minus 1 by one number less. So 1 minus probability of X less equal K minus 1 is less than 0.1. So from here, what do we get? If the 1 minus, so if this X less than K minus 1, it's going to be 0.1, then probability of X, let me write down this one. So it's going to be 1, plugging this 1, minus this piece, it's 0.1, will be probability of, hold on. It's not going to work. Hold on, let me do this way. Otherwise, this table also going to move. There we go. Or I'll move right here. This will be much better. Okay, so I'm doing 1 minus 0.1. This 0.1. So it's going to be equal 0.9. Okay, now what we are going to do here, so we need to have the K greater than K, X greater equal K is equal 90%. So what we need to find, which value of K is greater equal than 90%, 0.9. This is what we are going to do. Our probability is, so we are opening binomial cumulative table, which is also given with the problem. So since our probability is 0.5, once we open binomial cumulative table, And with n is equal 10, there we go, because there is a different n value table also. N is equal 10. Then I am taking 0.5 as a probability. And since I don't know how much my k is, which is this one is k, the whole this column is k, what I'm going to do, I'm going down by on this column under 0.5 and find the probability that is first number that is greater than 0.9. Hold on, I think it's gonna be, yeah, it's gonna be 0.9 right here. That's where from I found it. Okay, and once you come horizontally, you will see is equal 7. So we found it. K is equal 7. So because we have k minus 1, so we are writing down k minus 1 is answer, it's equal 7. So from here, k will be equal 8. That means passing score, it's going to be 8. You have to get as a minimum 8 out of 10, so you would pass the score. Okay? Okie dokie. See you next time.